Okay, everybody, can you guys see my screen?
Yes.
Yes,
Okay,
Professor.
Yes.
all right. So today's lesson is about new topic here. New topic we're going to use in some previous topics that we learned so far. So we're going to talk about what we call rational expressions. Okay, so that's our topic of the day, and it will be for the next at least 2 classes. First, let's define rational expressions. Or let's just make this a definition. So the short answer here, a rational expression is just basically a fraction. That's all it is, okay? Despite the fancy name, it just means it's a fraction. The only difference is this fraction is made of not just numbers, but also letters, like variables, x's and y's. So it's basically a fraction with basically polynomials. Okay, we saw what a polynomial is. It's just an algebraic expression with numbers and letters. Could be monomial, trinomial, binomial, and so on. So this is basically what a rational expression is, a fraction. So a rational expression. It's just a fraction with some polynomial here, for example, px, over some other polynomial, for example, q of x. So that's what a rational expression is. Not just the traditional fractions like this, but fractions with, let's say, 2x plus 3 over maybe x to the second minus 4x plus 1, for example. So these are, so this is a rational expression. This is just a regular fraction with basically integers. So what we're going to do basically is see how to add, subtract, multiply, and divide these, okay? Just like we do with regular fractions, when you find the LCD or multiply or do this or that, we can do all that with these as well. These take a little more time, more steps, because obviously you have more terms and numbers and letters, but the concept is generally the same concept. The way we multiply, the way we find the common denominator, and all that stuff is similar to regular fractions. So as we go, we'll be reviewing briefly the regular fractions and then apply the same concept to rational expressions. So again, rational expressions are just fractions which happen to have polynomials. And of course, just like with any fraction, you don't want the bottom to be 0. So q of x, whatever is in the denominator, it cannot be 0. Okay, whatever it might be, because division by 0, as you know, is undefined. If you divide any number by 0, this is basically undefined. Okay, if you try that in the calculator, divide anything by 0, you will get some error message or some message like this saying undefined or something like that. Okay, so that's all there is to it, basically, to rational expressions. And these, again, could be monomials, binomials, trinomials, but most of the time, there's going to be a variable in the denominator. Okay, so rational expression will be like this, with a variable in the denominator. At least one. Okay, so it's going to be a variable, some x or y, whatever, in the denominator. That's why we say the bottom can't be 0. We try to avoid any number that would give you 0 here because we don't know how to deal with that. That's an undefined, that would be something undefined, or when we don't know how to deal with it. Okay, so again, the short answer is just remember it's a fraction with x. Okay, rational expression, just fraction with x in the denominator. That's the short answer. And this is the technical stuff. We've seen all this before. We've seen polynomials, we've seen monomials and everything. And now let's talk about how to multiply these and simplify them and divide them. In the next class, we're going to see addition and subtraction. So let's start with, before multiplying, let's start with simplifying. So far is the introduction here, the definition. You guys got it? Any questions about the introduction or the definition of the polynomials? Okay, again, just remember this is a fraction. Let's take an example here and see if we can simplify it. Say 2x. Okay, so this is a rational expression here. Just like with the regular fractions, you know, when you have, for example, I don't know, let's say you have 15 over 35, which is a regular fraction. How can you simplify this fraction here? How can we simplify it if we wanted to?
You could divide it by 5.
That's right, we can reduce this by 5. So basically this is 3 times 5. 35 is 7 times 5. That's right. And what we can do is cross out the common numbers here, or the common factors. Basically, we just factored both numbers. We cross out the common ones. We end up with a simplified fraction. Okay? We can apply the same idea. We can apply the same idea to this. So what happens to this rational expression here?
You just keep the 2 and 5.
That's right. We can cancel out the common ones. Take that factor, cancels out. So we turn this rational expression into just a regular fraction here, as you can see, 2 over 5. So always simplify your, not only your fractions, but your rational expressions, because they may turn into something as simple as this instead of having this complex expression. So that's the whole idea of simplifying rational expressions. Cancel out the common factor. Sometimes if it's not factored, you want to factor it first. If it's not like this, for example, if you had 2x and plus 6 here and 5x plus 15, first you factor it, then simplify. Let's see an example of that. Say, for example, x to the second minus, let's say, 9 over x to the second plus. Okay, again, rational expression. It's made of 2 polynomials. The bottom cannot be 0. First of all, can we cancel anything right away?
Yeah, the x squared.
X squared.
Okay, so you might be tempted to do that. You see x2 here, you can cross them out. You may see also 9 and 6. You may think we can reduce this by 3, but we can't do that actually right away unless we have multiplications between the terms. It has to be in this form, some a times b, for example, over some, let's say, c times b. If we have a multiplication, we can cancel the b and the b. But if you have additions or subtractions, for example, like this, if you have addition and subtraction, you can't cross out the b. It stays like that. Unless you factor it first, and later, see, after you factor it, if you end up with some common factors, for example, here b and b are a common factor, then you can cancel out. So at this point, we cannot cancel the x2 and x2. We cannot reduce 9 and 6. So what do you think we do first?
Factor x squared minus 9.
That's right.
X 3, x minus 3.
Exactly. So we're going to factor this using binomial, or difference of 2 squares. Then factor the bottom. It's a trinomial. So we learned all these factoring previously. That's why I said it when we started factoring. It's going to be very useful. We're going to be using it a lot for different topics. And this is one of those topics, in addition to equations we did last time, quadratic equations and factoring. Okay, factor this then. The bottom will be
x and x.
Mm-hmm.
Is it plus 6 and minus 1?
6 and 1. Yeah.
Numbers are multiplied to 6 and add up to 5 are?
Plus 6x minus 1.
6 and 1 will not work because you won't be able to get 5 from them. Try again. Two numbers are multiplied to 6 and add up to 5. The numbers are 2
and
3.
3.
and 3. Okay. So factor. And what happens next?
Cut
What do you cancel?
x plus 3.
All right. Has to be exactly the same factor. Okay. Just like here, you cancel 5 and 5. Same thing here. So this is basically the same as this form. There's a product of two things. Product of two things. These are called factors. So 3 and 5 are factors. These also are called factors. That's why we call it factoring. Then you cancel the common factor. It has to be the exact same thing to be canceled. This and this cannot be canceled. Instead, we cancel these two. And what's left is x minus 3.
Over x plus 2.
That's right. That's our answer here. Can we cancel with x and x?
No.
That's right. No, because we have addition and subtraction here, as I explained earlier over here. It has to be multiplications here before you can cancel. It has to be factors. Means it has to be a product between the two. So for this one, so you can see it was a bit complex. It's much better now. Simplify it. So that's our answer. Okay. Do not cancel again unless you have multiplications between the terms, which we call factors. So we can factor any rational expression. You can simplify it by factoring first. If you can factor, if you can't, then that would be your answer. We took a look at another example. Actually, let's make this 8. So if we do x to the second plus actually, let's make this a okay, now another one here. So we're going to try to factor this and turn it and hopefully simplify it. Again, you can't just cancel now. You can just cancel x and x. We have to turn all these additions and subtractions into multiplication, and that process again is factoring. The first one here, what is the factor form? How do you factor this one? Yes.
2 open parentheses x minus 4.
That's right, 2x minus 4. The GCF is 2. On the bottom would be? Two numbers are multiplied to, I believe, should be negative 12 here to make things work.
12 and 1.
Not 12 and 1.
4, no. 4 and 3.
I have a negative 1 here. 4 and 3 and signs. Negative 4 and positive 3.
Plus
Okay,
3.
let's factor in. What we cancel now? What cancels after factoring?
X minus 4.
X minus 4.
That's right, those can be crossed out. So we end up with x plus 3. Again, you see how simple this looks compared to this one. So again, that's the purpose of simplifying. Always simplify your rational expressions. And everything we learn about factoring applies here, okay? Again, this is 95% based on factoring. The last step is just to cancel after you factor. So again, as I keep emphasizing, factoring is very important. Always try with start with GCF. If that works or it doesn't work, then you attempt to do trinomial, binomial, or sometimes grouping. It may work. Okay, it's all about factoring. Any questions, everybody, about this so far?
No.
All right. Okay, so that's simplifying rational expressions. Now let's go over to multiplication. Believe it or not, you can multiply these. For example, this and this, you can multiply them. Same way you do with fractions. And it gets even easier with factoring. So factoring is a very, very useful tool, like I keep repeating. It's very useful. It makes things a lot easier. So you may think this times this is a complex process, but it's not if you factor it first. So let's do that. Before we do an actual one with, with the rational expressions, let's try multiplying just some regular fractions. Okay, so if you were to multiply this, first of all, which way do you multiply fractions? Or how do you multiply fractions?
You divide, I believe.
You go straight across.
You would multiply straight
Multiply?
across. That's right, that's the rule. You would multiply straight across. But can we do something before multiplying straight across? Before multiplying the fractions, can we do something with them first?
You could cancel out diagonally.
That's right. We can cancel out. We can simplify them. For example, here we can reduce by 5. We can reduce here by 8 before actually multiplying. If you do that right away, you're going to get large numbers, large fractions. You still have to simplify, but we actually can simplify before. We can simplify before doing that. For that, we're going to basically quote unquote factor, because these can also be factored. Oh, one second. For example, 15 we can write as 5 times 3. And let me just use, that's 15. And we can cancel the 5 from these two later, so we can do this times. Same way here, what is the highest common number? It can go into both. Both 16 and 8, what goes into both?
4.
4, what, even better. What's better than 4?
8.
8, we can do 8.
Oh, wait.
8 times 2, and this one can stay 8 times 1. Okay, and at this point, we can cancel all the common factors between the top against factors of the bottom. Any numbers. It has to be one from the top, anywhere here, and one from the bottom. So what cancels?
5 and 8. The 5s and 8.
That's right. 5 and a 5. Can cancel 8 and 8. And we can now multiply just what's left at the top here. We have 3 and 1. And the bottom is 2 and 7. See, it's much, much simpler now to just multiply these than to do this. If you do this, you'll have to do it on the side, all the calculation and stuff, but this is pretty much done. And you get your answer in the simplified form. If you do, you multiply right away, you will get a large fraction, you still have to simplify it. So that's basically the concept of multiplying fractions. And since rational expressions are themselves fractions, the exact same concept applies to this. We're gonna do pretty much the exact same thing when you have when you have some rational expressions here. You factor them like we did, and before even multiplying, cancel out all the common factors and multiply what's left. Let's do that now with some actual rational expressions. So let's make some stuff up. So let's say 2, okay, x minus 5, for example. You want to times that by, let's say, x to the second minus 25. And let's throw in some trinomials. Something like this, and also maybe minus 6. Okay, so that's the type of question you'll see. Multiply these two. It seems complex. It looks like something that it's hard to do, but in fact it's not if you follow the same concept here. So what do you think we need to do first here? What happens now if we want to multiply these? What do we do first? You can always compare it to the previous example. Just the step, just the next step, not the actual answer. What's the process, or what's the step called?
Distributed property? I don't know.
We want to do the opposite of that.
Can we cancel the x squared? No.
Not yet. We cannot cancel these with these. We cannot cancel this one and this. It has to be in the form of multiplications. All has to be like this. Just like here, it has to be all multiplications. So what do we do to turn this into multiplications?
Times 2x and 2 negative 5. I don't know.
If you want to turn
Yeah,
this
the
into,
top.
if you want to turn this into a multiplication, this bottom here and this one and this, what is that process again?
Factoring.
Yeah, so that's it. Just factor first. So you can't cancel anything unless you have all multiplications. This is already factored. This here will be x plus 2. X plus 2, then times. What is that factor like? What's this if you factor it?
2 and 3.
Okay, and signs. Positive 2 and negative 3 over finally this, which is x plus 5. Okay, so now we're at this point here. So we kind of factored everything. And what do we do next? Everyone, what happens next now?
Can we cancel now, Professor, or no?
Remove x plus 2 and remove x minus 5.
Exactly. So we can cancel all the common factors. One from here against one from here, just like we do with the numbers. So you don't want to multiply all this right away. It's going to be a whole. It's going to be a mess, and you still have to simplify and combine like terms and factor and simplify again. So you don't want to do that. You don't want to multiply right away. Instead, once you factor it, about half of it would go away, and you can end up with something as simple. For example, here, instead of all this, we got into this. So looks like we have x plus 2 common. What else? What else cancels?
X plus 2, the other one.
No, it's just one against one.
I know 5.
The 5s, the 5 and the 5. There's nothing else common left. So as you can see, now it's just going to times 2 by what's left here. Okay, 2 times this, and x plus 2 times x plus 5. And that's it. We did the multiplication without doing any actual multiplication. That's your final answer. The good news is you don't have to distribute it. You don't have to distribute this, even though it's called multiplication, but let's leave it like that. It's convenient when it's factored. You may need it to do other things, like solving something or adding something. So just leave it like that in a factored form. Okay, does that make sense, everybody?
Can we do another one, Professor?
We're gonna do other examples. So let's see, x. x plus 5 and x minus 4, for example. You want to times that by, and even add something here. So it's 2x minus 2 here, and and probably it's 2x minus 1. And over here, okay, this one is already factored, so we don't have to factor it. So what happens next? We want to multiply these two fractions or rational expressions. What do we do now?
Can we cancel it?
That's right, we can cancel. So again, you don't want to multiply it right away. If you multiply all these, again, it's going to be a lot of work. Just like here, you don't want to do 15 times 8 yet. You don't want to do 15 times 35, even though you could, technically correct, but it's going to be a lot of work. Instead, factor all, cancel, and multiply what's left. That's what we're going to do here. As long as you cancel one from the top, and cancel one from the bottom. But before you cancel, make sure you have multiplications here. You have a multiplication here and here, multiplication here and here. Unlike here, you can't just cancel x2 and x2 because these are not multiplications between them. That's why we factored them first. For this one, luckily it's already factored. So we can cancel x minus 2 and minus 2. What else cancels out?
Minus x minus 4.
That's right. X minus 4, x minus 4. Anything else common to cancel out?
No.
That's right. So we're just going to keep what's left. We have x plus 5 here and x plus 2. And then we have 3 and x minus 1. And that's all. Okay. Again, even though the process is multiply, that's it. Just leave it in a factored form. It is a multiplication, so just leave it like that. Like I said, this is useful, can be used for other things. Okay, does that make sense to everybody?
Yeah.
Everyone, you got this?
Yes.
Everybody else, I don't hear from everybody. Are you okay?
Yes.
Okay, it's very simple. Again, all about factoring. So if you have problem with factoring, you should go back to the 2 lectures we did on factoring. We explained this in detail in 2 lectures. This process here is factoring. So again, more than 90% of this is just based on factoring. Then you just cancel stuff out. Let's do one more example with just some monomials, not all these trinomials, binomials. Let's say CF14 and maybe so you want to multiply this by some other expression. Actually, let's bring this 5. Same idea here. We want to multiply these two. Okay, these are even smaller than these. So what do you think happens first?
We can cancel the 14 and the 21.
That's right. We can reduce these two here. You can see. What else?
Then we can cancel the 5 and the 10.
That's right. So 14 and 21. 7 goes into both. So 7 into 14 twice. 7 into 21.
3 times.
That's right. Then we have 10 and 5. You can reduce them by
1/2.
That's right. 5 into 5 once. 5 into 10 twice. So now we're done with the numbers, at least. So let's multiply those first. So We have 2
This will
and
be
2 left.
4,
And
3.
1. Good. Now, what do we do? We have x3 over x5. What is x3 over x5?
X2.
3 minus
We'll
5,
make-
which is
yeah.
1 divided by x in the exponent of 2.
not 2, but I mean, you flipped it. Okay. So before you flip it, it's this. So if we subtract these, it will be x minus 2 here. And later we're gonna move it down. What about y7 over y2? That would be,
y5.
that's right, y5 will subtract. And it will be y5. Almost done. As always, make your powers positive. Move that down. Turns into 3 y5 and x2. Okay. So these are even easier because we didn't have to factor. Technically, it's already factored. We have multiplication here, here, multiplication here, and here. That's why we canceled the right away. We couldn't cancel here, for example, the x2 and x2, because we had additions and subtractions. Okay, so basically we used the rules of exponents we learned a while ago.
Professor, where is 4 from?
The 4 from 2 times 2.
Okay.
Okay, and 1 times 1. So after we simplified, we just multiply straight across, just like here. 3 times 1, 2 times 7, 14. And that's pretty much how you multiply any rational expression. So keep in mind, you need to know how to deal with fractions, the regular fractions first. If you have issues with fractions, check the videos, the channel. I have Math 2 lectures, lecture 1 and 2. I talk in detail about adding, multiplying, subtracting regular fractions. So you need to know your fractions. Secondly, you need to know how to factor. Again, we did a couple of lectures on this. And the rest is just basically simplifying. And of course, you need to know the rules of exponents. And the process is not that bad, okay? Mostly factoring and canceling. What else? Any questions, everybody, before we go to division?
So Professor, how come you cross multiply 2 times 2?
Mhm.
Well, you multiply cross, but for the square, you cross multiply.
I cross simplify it, right?
Yeah, how come it wouldn't be like 7 minus 5? You see the y7 and the x5?
Mhm.
How come it wouldn't be that way?
So this 7 and this 5, right?
Yeah.
Because see, the bases here are different. That's why we didn't subtract these this way.
Okay.
Okay, but if you had y here, if this was also y, then you would subtract here.
Okay.
So we multiplied straight across, but we simplified these two basically. We cross simplify because we look
Okay.
for the same variable, okay?
Same variable. Okay.
All right. Sometimes you may see x here and x here, then you would simplify here first.
Okay.
If you multiply these, x3 and y7, nothing will come out of them because the bases are different.
Okay.
Same thing here, we didn't multiply x and y, nothing's going to come out. So instead, we looked for the similar variables.
Okay.
Okay, so that's basically the division of rational expressions. I mean, the multiplication. The division is all of this plus one extra step in the beginning. All of this and one extra step. Same stuff will repeat again. And you may already know that step from dealing with the regular fractions. Again, before we do an actual example with the rational expressions, let's take some random. Let's see some. It's the review, actually, division of just regular fraction. Let's say you have this, maybe 5 here. And possibly 14 here and 7. That's a division with the regular fractions. So how do you divide regular fractions? Let's say you had this question, divide these two fractions. Forget about rational expressions for a moment. How do you do this?
You can just overturn the second fraction, like to make it not 5 divided by 7, but 10 divided by 14 multiplied by 7 divided by 5.
Exactly. So whenever you have a division of fractions, we can turn that into multiplication simply by keeping the first one the same. You turn this, change this to a multiplication. At the same time, you need to flip this. So we flip this upside down. We get what we call the reciprocal. 5 or 7, flip it over, becomes this. Once we turn your division into multiplication, then again, the whole thing applies here. Everything we've done applies to this. Is there any way we could, do we multiply right away, or do we do something else?
Cancel it, Professor?
To reduce?
Exactly. Always cancel or reduce before you do anything. Again, you want to get smaller numbers, so
5 into 5, 1, 5 into 10, 2.
that's right. And here,
7 to 7, 1, 7 to 14, 2.
exactly. And much easier now just to multiply these two. So 2 times 1, 2 times 1, which is basically 1. Okay, 2 times 1, 1 times 2, and you can see we turned that into a 1. The exact same concept again, and steps apply to rational expressions. So let's do that again with something like this. As complex as they may look, you see that we can do that in 2 steps. We take literally a couple of minutes to do. But again, if you have issues with the fractions, we did that in Math 2. So if you check the channel, go to playlist Math 2. The first and the second lectures are just about fractions. All stuff, simplifying, addition, adding, multiplying, division, all that stuff is in playlist in the channel Math 2. You can go back and check that out if you have issues with fractions. Let's do now something with some actual, let's say, one with actual rational expressions. So we can do something like this. Probably 15 here. Maybe some y or some x actually. And maybe 4. This is going to be a y here. Okay, now we added some x's and y's, but again, we're going to do the same thing. So what's the first step? So what we call, by the way, we call this keep, change, flip. If you recall that on fractions, keep first one, change the division into a multiplication, and flip. So flip is when we flip the second one. Only the second one flips. We get what we call the reciprocal. So let's do that first. Because of the division, do not cancel. Actually, I messed up the numbers. Do not cancel anything yet, okay? Because it's division, you have to first turn it into a multiplication and then simplify. Let me actually switch the numbers a little bit here for convenience. Let's make this 15 and 8. That should be better now. Okay, so the first thing you want to do again is keep, change, flip, and keep the first one. Do not cancel anything yet because of the division. So it's going to be first one stays the same. Turn the division into a multiplication. Flip this one. Once you do that, and again, the same process we did here with multiplication applies. So what happens next?
cancel.
That's right. So we're 25. 15 we can reduce by 5 will be 3 and 5. And here we're going to reduce by
4. So it'll be 1, 2,
and 2.
2. Mm-hmm.
Okay, so we got rid of the numbers. Just multiply them. 5 and 2, that's 10. 1 and 3, that's 3. Let's see what we do what do we do with the x's now? We have x4 here and x4 here. What do we do with that?
We have to subtract.
But they happen to be on the same side. So basically we're multiplying now. x4 times x2 will be
X8.
not 8, but
6.
6. That's right. Here we add the fractions. Here we subtract them. So the difference here, they were, one was up, one was down. So it's basically a fraction. That's why we subtract. But here they happen to be on the same side. So you multiply them straight across. x4 times x2 is x6. And what goes here?
Y5.
Not 5. Again, they happen to be on the same side. We have y2 and y7. So we'll multiply them.
9. Y9.
That's right. So basically we're multiplying straight across everything. Because the x's happen to be on the same side. If this x was here, again, we would divide x4 by x2. They happen to be on the same side, so we multiply them. It would be
Y9.
That's right. y2 times y7 is y9. And that's it. Okay, that's the final answer here. 2 steps. Keep, change, flip, and simplify. Keep, change, flip, simplify, and then multiply actually. So 3 steps. So division, again, is just one extra step from multiplication. Whatever you do with this, whatever we did with the multiplication here, also applies to division, but first do the keep, change, flip. Okay, so this was with just monomials. Now let's do a division, a long one now with maybe something like this, but with a division here instead of multiplication. That's probably the longest and the most complex you'll see. But again, it's just a few steps. All right, so let's make some stuff up as usual. Let's see, maybe 7x here plus 10. We can divide that by some, let's say x to the second, maybe minus 25. And let's see, 3x, maybe minus 6 here. And finally, minus 6 plus, let's make it 5x. And let's see, plus, so this one, to make this right, let me flip these. Okay, that will be divided by, over here, maybe x minus, let's say 6. Like this. All right. Okay, so we have a lot going on here. Looks like a complex operation, but it's not. Again, break it down into a couple of steps. What is the first one?
Keep.
That's right. Keep, change, flip. Okay, whenever you have a division, the first thing you want to do, turn it into a multiplication first. Don't change anything yet. Only do this, keep, change, flip. So multiply, so x to the second minus x minus 6. Okay, only flip the second one, and the division turned into a multiplication, so it would be x to the second minus 25. Okay, that's the first step. What else? What's the next step? So keep, change, flip. You have a multiplication. Does that look like this? I mean this. So now we're at this point. So what happens next?
Can we cut it?
Do we cancel, Professor?
Can we cancel right away? Look again. What did we do from here to here before canceling?
Factor?
That's right, factor. There's nothing to cancel yet, even though you see x2 here. We can't do that. It has to be, see the trinomial turned into multiplication, this one turned into this. So factor before you cancel.
So the first number,
Okay. We're gonna factor all that using all the factoring techniques. So the first one will be
x,
Mhm.
x, 5 and 2.
Very good, 5 and 2. The next one, 3 and
3 and 2.
X minus 2.
that's right, multiply. And over here, x,
2 and 3.
2 and 3 on the signs, plus and minus.
Plus and
Positive
negative.
and negative, yeah.
Plus and minus. So that way they multiply to -6 and up to -1. And finally,
X minus 5, X plus 5.
exactly. And we're almost there. What happens next? The fun part. Almost there, right?
Cancel.
Mm-hmm.
Such when-
Here's the 3.
X plus 2, X plus 2.
That's right. We have x plus 2. Hold on a second. This x plus 2 cannot cancel against this one because they're on the same side. You can't cross them out. You can't cancel against this one either because they're not exactly the same. So that does not cancel. What cancels instead?
What about the x's? No, Professor?
Not individually. You're looking at factors. Multiplication. So this is a
Oh,
factor.
so the +5 and the -5? Yeah, on this x.
Plus 5 and
X minus 5. Okay, +5, yes. X plus
this
5.
the exact same one, okay? And again, look for something else that matches. It has to be the exact same thing. We have x plus 2, here it's minus, so we can't cancel those. But they're not the same. We can't cancel 2 and x and 2 and 2 again. We cancel them in factors, not individual numbers. We can't cancel this x plus 2 and x plus 2 because they're on different sides. It has to be one from the top, again, against an exact match from the other side. At this point, looks like nothing else will cancel. So let's see what's left. At the top here, we have these 3 factors left, this, and this. We're gonna write those. And x plus 2. That's fine. If it looks like that, that's all right, not a problem. And here is canceled. We have these 3 left. And that's all. As you can see here, made a mistake. Okay, that's good. 3x plus 2, x plus 2, x minus 3. Nothing from here matches something else from the bottom. It has to be the exact same thing to cancel out, and that stays the same. And again, no need to really distribute and multiply. It's better left like this. It can be used for other things. If you have another question based on this, you may need to, I don't know, add or solve or subtract, do some other stuff. Always leave your stuff like this factor. It's the best form. Okay, any questions about this problem? Again, this is as complex as it can get. Break it down into 3 steps. If it's a division. Okay, this applies to division. You do these 3. Keep, change, flip, factor everything as much as possible. You may have to factor another time if you have trinomials or binomials, but always try GCF first and then another method. Once you do that, you cancel all the common factors. Again, make sure it's 1 from the top, anywhere here, against an exact match from the bottom. That's the reason we didn't cancel this against this or this against this. Instead, x plus 5 canceled against x plus 5, not against the x minus 5. And I believe that's pretty much your operations with rational expressions, okay? Simplifying, multiplying, and dividing. Addition and subtraction is different, are different. So they require, just like with the regular fractions, what do you need to have when you add and subtract regular fractions?
The common denominator.
Exactly. So when you add